So how do you find the domain of a logarithmic function? Well, remember in the previous lesson, we learned that the argument, do you remember what the argument means? It's this stuff here. The argument cannot be negative and it cannot be 0. That means the argument must be greater than, not or equal to, just greater than 0. Let me get that off of there so nobody gets confused. The argument must be greater than 0. That's how you can find the domain of your logarithmic function. So find the domain of this one. You take your argument and set it greater than, I keep putting equal to, you set it greater than 0. Subtract 3. So x must be greater than negative 3. Remember, in graph form, if x is greater than negative 3, it looks like that, right? That means our interval notation is negative 3 to infinity, and you have a parenthesis here because it cannot equal negative 3. So what about the domain of this function? Remember, just take your argument and set it greater than 0. 5 minus 2x must be greater than 0. So we're going to subtract 5. We'll divide by negative 2. When you divide by a negative in an inequality, remember you have to flip the inequality sign. And that's just going to be 5 halves. In interval notation, that would be negative infinity to 5 halves, not including 5 halves. So let's talk about all of the characteristics of a logarithmic function and its graph. It's kind of hard to fit all this on the screen, but let's see what we can do. First of all, it's 1-to-1. Well, first of all, it's a function because it passes the vertical line test. It's 1-to-1 because it passes the horizontal line test. It has a vertical asymptote at x equals 0. That's this line right here. The domain, remember those are your x values, would be 0 to infinity, but it does not include 0. Okay, so the domain is 0 to infinity. The range is everything because it keeps going up and it keeps going down. So that means it covers all of the y values. So the range is everything. There's an x-intercept at 1, 0. There is a key point at B1. Now what is B? B is your base. Okay, so at B1, there is a key point. Kind of helps you know which direction to go. It does not have a y-intercept, mainly because the y-axis is a vertical asymptote. Your function is increasing if your base is greater than 1. This is an increasing function. If your base is between 0 and 1, say maybe b is a half. If b is between 0 and 1, it is a decreasing function. So we do have all of these shifts that we learned in a previous lesson. Remember, the horizontal shift is always inside the function. If it's inside, it goes opposite of what you think. So if there's a number right there where the c is, we have plus c, it's going to go to the left that many units. And if it's minus c, I said the wrong way, the left, that's what I meant to say, okay? So if there's a minus c, that means it's going to go to the right that many units. Okay? It's one of those things, do what I say, not do what I do. Alright, so then if you have a number that is added or subtracted outside the function, I want you to notice the difference between this one and this one. This c is inside the logarithm. It's inside the function. This d is outside the argument, right? It's outside the function. This is a vertical shift. It will go up d units or down d units. All of this information is exactly the same as all of the other transformations that we learned about. We have a vertical stretch and a vertical compression just like before. It's the same thing. So look at the difference. This one, this blue one, represents our original parent function. Okay? If you have a number here that is greater than 1, right? You have a number here that's greater than 1, it's going to stretch your function, so it's going to get tall and skinny. Exactly the same thing that we talked about before. If you have a number in front of your logarithm that's between 0 and 1, it's going to compress it, so it's going to make it short and fat. So this blue one is the parent function, and if we put, say, a 1/2 right there, or a 1/3, or a 5/8, anything that's between 0 and 1, then this is going to be compressed, so it gets short and fat. Then we have reflections involved. Looking at our function, this says if b is greater than 1. If b is greater than 1. Actually, it's going to reflect about the x-axis if there's a negative here. That's the way that I would like for us to learn this one. If there is a negative here in front of the function, it's going to reflect over the x-axis. And then it reflects over the y-axis, just like we learned before. If the negative is inside the function in front of x, it reflects over the y-axis. These should be exactly the same as what we learned before. So on this last page, we have a summary of all of those transformations that could be happening. So let's just look at this example. What in the world is going to be happening? Well, first of all, the base is 3. So we're going to say the parent function is, we'll call it g instead of f this time, is log base 3 of x. That's going to be our parent function because that's base 3. So tell me, what do all of these things do? Well, first of all, we have that negative. This negative, what is it going to do? It's in front of your function, so it will reflect over the x-axis. What's the 2 going to do? The 2 will stretch it. So that one's going to be a vertical stretch. And then we have a 4 inside the function. What is the 4 going to do? It's plus 4. That means it goes left 4 units. And then we have a plus 5 outside the function. What does the 5 do? Since it's a plus 5 and it's outside the function, it's going to go up 5 units. Let's just graph both of those and see what they look like. So we have, actually I'm going to graph these, but we're going to talk about how I did this a little bit later. So that's going to be the parent function, the first one that you see. Okay, this one's going to be a little more difficult to type in the calculator. Hopefully that works. I'm not sure it will, but hopefully it will. So the first graph that we see will be the parent function, and then the second one will be the one that's been transformed. Wow, that is some crazy graphing right there. So whenever we are working with these, at least in my class, we don't have to do all of this. We can state the domain. X plus 4 has to be greater than 0. So x has to be greater than negative 4. That means your domain is negative 4 to infinity. So I do want you to be able to find the domain and list the transformations, but you don't really have to do this part for me.